Morning, everyone. Today we're going to be working on writing equations given a real world scenario. So we're going to be working with our word problems and just how we can write an equation, because then we can use that equation to either identify the slope. We could use the equation to graph. We could work with a table. So there's lots of different things that having this equation can help us with. For our equations today, we're going to be focusing on both proportional and linear relationships. The nice thing is, whether it is a proportional relationship or a linear relationship, the way that we write these equations is very similar. So that's why we're able to do both of them today. And just wanted to provide you with a quick little snapshot here of some key words here is when you're dealing with word problems, whether it's an expression or whether it's an equation like we're doing here today, these are some of the most common things that you'll see to help you know whether you're adding, subtracting, multiplying, or dividing. Now, for all of our things today, since we're dealing with proportional and linear relationships, they are going to be in this form, slope-intercept form, y equals mx plus b. That's kind of nice. It can kind of give you a guide to help you until you get a little bit more comfortable and could recognize this when it's mixed with other types of problems. It's nice to know that for today, you have this equation, you have this guide as you're writing them. Please recall that B, your y-intercept, is where the graph begins. So that's another way of saying it's the initial value. So when we're working today, we're going to be looking for where do things start? What is the initial value? And that is our B. That is our y-intercept. And then remember your M for slope, it's the movement. It's how either steep or how less steep, how fast, how slow your graph is moving by, increasing or decreasing. Well, another way that we can, refer to this is rate of change or unit rate. Typically, we call our slope the rate of change when we have a real world scenario. So we can kind of remember that vocab matches with it, because if it's how much it's changing by, it's how much it's moving. And then rate is kind of like another name for, speed, either quickly or not very quickly. All right, let's just go ahead and dive into that first example, and hopefully we can take all these little reminders, we can piece them together and start to make sense of this. So suppose that the water level of a river is 34 feet and that it is receding at a rate of 0.5 feet per day. Write an equation to represent this scenario. Okay, so I've read it once. That kind of helps me get the gist of it. We're talking about water levels here. Now I'm going to read it again and see if I can pick out some information. So suppose that the water level of a river is 34 feet. That sounds like a starting amount to me. That sounds like an initial value because it's telling us that it is currently at 34 feet. So that is going to be our B, our y-intercept. And it is receding. What does the word receding mean? Increasing or decreasing? Receding means it's decreasing. So I definitely want to make note of that, because that means I'm going to need to have a negative somewhere if it's decreasing. And how much is it decreasing by? Well, it says it's decreasing by a rate of 0.5 feet per day. Well, there's a couple things here that can lead us to recognizing that this is our rate of change. One of them is it pretty nicely right here just says it's our rate. So our rate of change, remember, is another word for slope. Another thing that helps us note this is right here where it says foot per day. If you guys recall back to the very beginning of this unit when we talked about unit rates is the rate per 1 unit. Well, this is telling us that it's going half a foot per 1 day. So that word per there kind of helps lead us to, hey, this is our unit rate. This is our slope. Now that we've identified this information, we're being asked to write our equation, and we actually have all we need because we're writing our linear equation in sloped-intercept form. So we have y equals m. Now, what was our slope again? I want to be careful. Yeah, so we know that it's 0 and 5/10, but it was receding. So make sure we have a negative 0 and 5/10 as our rate of change, as our slope. And then the water level started at 34 feet. There's nothing there telling us that it is below sea level or it's underground or anything. It's just a straight up water level of 34 feet. So it would be a plus 34. It would be a positive. And that is actually it. You now have the equation that matches this scenario, and then you would be able to go forth and graph it if you were ever asked to graph it. Or you would have the equation that could match up with the table, and you could, use it to assist in those forms. We're not going to really be focusing on the tables or the graphs today, just so we can get lots of good practice on writing the equation, but just wanted to kind of remind you of why this is beneficial, how you could then use this to help complete other tasks. All right, let's try another problem here. So let's go ahead and read the problem first before we read my little note at the top. So example 2, for babysitting, Nicole charges a flat fee of $3 plus $5 per hour. Write an equation for the cost C after H hours of babysitting. This time it's telling us to use C and H as our variables. That's okay. We're still writing linear equations here. It's just instead of using Y and X, we're using C and H. This can happen when you have real world scenarios because sometimes it is helpful because then we can remember what the cost is, what the hours are. So we'll kind of figure out which one's which in a moment. But now let's read back through the problem and try to identify our slope and our y-intercept. So I see that Nicole is charging a flat fee of $3. Well, that flat fee means no matter what, you're going to have to pay her $3, no matter whether she babysits for you for an hour or maybe it's an overnight thing and it's 24 hours. You got to pay her $3 no matter what. So that is our initial fee. That is our y-intercept. That's where we're starting. And then we also are charging $5 per hour. Well, that would be our rate. Because remember, a couple key things to help us know it's our rate is that word per. And then we see it's per hour. So that's our unit rate because it's $5 for every single hour. So that's our M, our slope, our rate of change. Now, we're using C and H as our variables. How do I know which one is the total, which would be Y, and then which one is our X? Well, a couple things here is if we're looking at this, when we're writing our equation, we're going to end up figuring out how much, Nicole is going to get paid. Or how much, if we look at it from the flip side, the people are going to have to pay Nicole, what it's going to cost them to hire her as a babysitter. So that total value is going to be our Y. Because remember, our equation starts out as Y equals. So that Y can be thought of as our total, which would be our cost C. And then another thing that helps us note that is if we look here at hours, notice that H for hours goes along with our slope. And whenever we write our equation, our slope is being multiplied by our X. So since it's $5 per hour, we're taking $5 times the amount of hours that they work. Or in this case, $5 times H. So let's piece this all together and write our equation here. Instead of Y equals, it's C equals because it's our total cost. And then we have $5 per hour. So instead of 5x, oops, I almost wrote 5x, it's 5h. And then they also have to pay $3. That's an additional fee. It would be plus 3. That's 3 extra bucks. There is our equation. All right, this one here is multiple choice. So after we read through this, I highly encourage you to pause the video, see if you can pick the answer, and then, resume the video to check yourself and see if you got it correct. So up here at the top is just that reminder from the first slide, remembering that we are doing it in slope-intercept form. B is your initial value. M is your rate of change or unit rate. So a canoe rental service charges $20 for a transportation fee and $30 an hour to rent a canoe. Write an equation representing the cost Y of renting a canoe for X hours. All right, pause the video, reread, and see if you can figure it out. All right, at this point, we're going to go over the answer so we can see if you got it correct or not. So as we go through this and I read it again, I notice that we're being charged a $20 transportation fee, which makes sense. If you're renting a canoe, they probably got to take you to the river or to the lake. So they're going to have to charge you that extra money. So that is a fee that we have to pay no matter what. That's that initial value, that starting point. That would be our B, our y-intercept. And then it's going to cost us $30 an hour. This time, instead of saying per, we used the word and, but I can still see that we're having dollars for each hour, $30 every hour. That's our rate of change. That's our unit rate. That's going to be our M. And then we're still using our our variables Y and X. It's just kind of letting us know that Y is that total cost and X is the number of hours. So remember, that can kind of help us find our slope a little bit, is if we know that our X is representing hours, we're going to be looking for a number that is related to hours for our M right there. Okay, if we look at our answer choices here, it looks like B is our winner because it's $30 per hour and then a $20 transportation fee. So if you picked B, you got it correct. All right, let's analyze the other two options. Any ideas what happened with C? Just got the numbers mixed up. So yeah, accidentally thought it was $20 an hour and then a $30 fee. So C, they just got the numbers backwards. And then A, it looks like they were added together. But they can't be added together because it's 20 bucks no matter what, but then it's an additional $30 every hour. So that's your rate, that's your movement that's going to be changing depending on how long you rent the canoe for. So B is that correct answer here today. All right, we're going to go through two more problems together. The first thing we're going to do is we're actually going to apply it a little bit. We're going to write an equation and then use that to help us solve and find out an additional step, an additional piece of information. All right, write an equation that will model the proportional relationship given in each real-world situation. There are 3 cans that store 9 tennis balls. Consider the number of balls per can. A, find the constant of proportionality for this situation, and what does it mean? Okay. So we are being told in this case that it's a proportional relationship. And remember that proportional relationships are linear. So you could continue to, think about the equation y equals mx plus b. Just if it's proportional, then your b, your y-intercept, is always going to be 0. So there's no extra charge or anything like that. Which is why typically when we talk about proportional relationships, we write it in this format because it is showing us that, hey, there's no b here because in order for it to be proportional, it has to start at the y-intercept of 0 for the origin. And then just to help us kind of differentiate, we use a K instead of an M for constant of proportionality. So we're being asked to find that constant of proportionality, otherwise known as slope, otherwise known as rate of change, otherwise known as unit rate for this situation, and explain what it means. So when I'm looking at this, I'm being asked to consider balls per can. So I need to figure out how many balls there are in every can. And we have 3 cans that store 9 tennis balls. So if we kind of want to draw a picture here, we have 1, 2, 3 cans. And between those 3 cans, there are 9 tennis balls. Well, we could put 1 in each. That gets 3 total. We put a second one in each. That's 6 total. And if we put a third one in each, that's 3 total. So we have 3 tennis balls per can. So 3 tennis balls per can. So we just actually did a 2 for 1. We found the constant of proportionality and what it means, because what it means is that we have 3 balls in every individual can. So a lot of times that meaning is adding that label. It's not just saying the answer is 3. Well, so the constant of proportionality is 3. And then for what it means that every can has 3 tennis balls. So if we want to write an equation, represents this relationship, y equals 3x. 3 tennis balls per x number of cans. And then you could apply this to find others. So let's go ahead and quickly actually add part C to this problem here. All right, so just added part C over to the right here. So how many tennis balls would there end up being if you had 5 cans? Well, we just talked about the fact that if it's tennis balls per can, that means X represents the number of cans. And we have 5 total cans, so we can substitute 5 in for X, find the total. So Y is equal to 3 times 5, because there's 3 balls per can and we have 5 cans, giving us a total of 15 tennis balls. Perfect. All right, last problem here. So write an equation that will model the proportional relationship given in each real world situation. In 25 minutes, Lee can run 10 laps around the track. Consider the number of laps she can run per minute. So find the constant of proportionality and what does it mean? So we're given some totals here. It takes in 25 minutes, Lee can run around the track 10 times. And we're wanting to try to find how many laps she can run per minute. Well, I see that word per there. That means I'm looking for a unit rate. Remember, unit rate is another name for constant of proportionality. So if we can find that unit rate, we'll have the first part for answer A. Well, remember with unit rates, when we're writing that ratio, we have to watch the wording so we can make sure we get things in the right order and not backwards. So it's laps per minute. So we need to take 10 laps per 25 minutes. And if we divide that, we will get that she can run 4/10 of a lap in 1 minute. So our constant of proportionality is 4/10. And what does it mean for the situation? Well, it means, let's type this here so it's a little nicer looking. It means that Lee can run 0 and 4/10 of a lap in 1 minute. Now let's take this information and write an equation. It's a proportional relationship, so it makes sense that there's no other numbers involved here because we don't have any initial starting value. We just need to rewrite this as y equals 0 and 4/10 x. Perfect. All right, I hope that this video helped give you a better understanding of writing proportional relationships and linear relationships from a word problem. If you have any questions, please make sure to reach out so that way we can practice. Of course, make sure you come to help sessions and ask there as well. But if you need anything, let me know. Otherwise, make sure you guys move on to your next task and your next assignment for the day. Thank you. Bye.